This video is part of a series. It's heavy in scientific terminology and may expect familiarity with previous videos. If you're confused, please watch the rest of the playlist up until this point, or check out my genetics terminology document, both of which are linked in the description. Thanks! Leucism and albinism are both types of true white, aka total depigmentation, rather than false whites like chinchilla, where there's just very little pigmentation. But leucism, or leucistic white, works very differently from albino. Albino has to do with the deactivation of pigment production. Leucism, on the other hand, has to do with failure on the part of melanoblasts, which become melanocytes, which produce pigment, from reaching their destinations in the first place. As a reminder, one gene that causes multiple distinct traits by itself is called a pleiotropic gene. White dominant is a pleiotropic gene. Or, more specifically, it's a pleiotropic allele that shares a locus with a few other alleles in the KIT region of chromosome B1. White dominant causes a cat to be totally white. It looks almost exactly like albinism, and like albinism is epistatic to every other color. Although, unlike albinism, the eyes are never pink, and they still reflect green or yellow instead of red. White dominant eyes can be any color, including blue. This is because blue is the color that eyes are underneath pigment. Yes, I know, I hear you. Yes, baby, I know. I apologize if you hear my cat meowing during any of this video. She is extremely loud. Last time I recorded, we did not have this cat. But she does have leucistic white on her, so I think it's thematically appropriate. This is because blue is the color that eyes are underneath pigment. Blue eyes are what happen when a cat's eyes have no pigments, just like how white is what happens when a cat's fur has no pigments. You may have heard that blue-eyed white cats are deaf. This does have a scientific basis, but there's more to it. This is where pleiotropism comes in. You see, all kittens are born deaf, but their ears quote-unquote open about 10 days after birth. The allele for white dominant, WD, in addition to preventing pigment-producing melanocytes from reaching their destinations, also causes important hearing cells to degenerate. By the time these kittens' ears open, those ears no longer work. Being blue-eyed doesn't cause deafness so much as it is a sign that something's going on up there. Sources vary, but the chances that a blue-eyed white dominant cat will be deaf tend to hover around 65 to 85%. White-blue deafness is largely polygenetic, so it's really hard to pin down the exact inheritance, but in a deaf-deaf pairing, about 70% of the kittens will turn out deaf too. White-dominant cats with only one blue eye have a decent chance to be deaf in that ear, the one on the same side of the head as the blue eye, with normal hearing on the other side. And, of course, being called white-dominant, it's dominant over everything on this locus. White spotting, on the other hand, doesn't seem to be associated with deafness. It's been debated for a long time about whether white spotting exists on its own locus, and if that locus is linked to white dominance locus, or if they share a locus. I'm going to go with the model that they share a locus, because that's the one I could find the most sources and gene testing for. And in order to test for a gene, you need to have a pretty damn good idea of where it is. There's a lot of different letters that people use for white spotting, but I'm going to use S because it's the one that I see the most. S is codominant with full color W, and causes white patterns on cats. Heterozygous SW cats will have white that covers less than half their body. Homozygous SS cats will have white that covers more than half their body. Homozygous SS cats can be completely white with no traces of color, but this is very rare. It's more likely for cats to have some splotches of color remaining on the top of their heads, called van markings. Breeders measure how much white a cat is by using a grading system. There's 10 grades of white, starting with grade 1, which has the least amount, all the way up to grade 10, in which the cat is totally white. Cats with any kind of white pattern are called bicolors, but there's a lot more specific names given to specific patterns. Just a few of them include van, mask and mantle, cap and saddle, tuxedo, or just tux. There's way more. But cats with the same amount of white usually end up with different patterns of white. In fact, most high-grade white cats don't fall into the CFA's neat little white pattern boxes. Look at any calico and you'll see some crazy shapes. The actual exact pattern of white spotting is highly polygenetic, probably affected by development, and currently totally unpredictable. Selective breeding can lead to a more uniform pattern, but that's about it. That being said, we do understand the mechanics of white pattern formation in fetal development. We touched on it when we talked about calicos back in the ginger video, but here it is. Melanoblasts, which become melanocytes, follow their pathways along the body and then settle. As the fetus develops and expands, cracks of white between the islands form and expand, since there's not enough melanocytes to fill them in. This process is called pigment drift, which is a reference to continental drift, invoking the image of islands of pigment floating along an expanding ocean, bumping into each other to form bigger islands. The reason cats tend to be white at the bottom is likely because the belly area expands the most during development. You can get pretty creative with white spotting patterns, but the most realistic designs keep in mind that the underside of the cat is the most likely to have the most white, and the regions furthest from the belly, especially the head and tail, but also the toes and spine, are the most likely to end up pigmented. As white spotting is a form of leucistic depigmentation, it can also lead to blue eyes and pink leathers. Having white markings close to the eyes/leathers makes it more likely they'll be blue/pink. It might also only turn one eye blue, or only turn part of the leathers pink. There's actually a secret fourth allele on the W locus. This allele is fixed in the Birman breed, meaning Birmans always have 2 copies of the allele, but it's not super common in other breeds, so I'm only going to cover it briefly. It's represented by G, and it causes white feet. One of my sources says it's codominant, wherein GG homozygotes just have white feet, but GW heterozygotes have white feet and sometimes other white spotting. Another source says it's recessive, so only GG homozygotes will have white feet, and that it sometimes causes other types of white spotting anyway. The source that claims G is totally recessive sells DNA testing kits for that gene, so I'm going to lean more towards that model being correct, since in order to test for a gene, you have to understand it pretty decently. Both sources are both linked in the description. No sources I could find mention its interactions with S or WD, though I can't imagine WD not being dominant over it. In summary, the W locus has 4 alleles. WD always causes a fully white cat. If the cat has blue eyes, they may be deaf, and if the cat has just one blue eye, they may be deaf on that side. S, which causes white spotting, is codominant with W. Heterozygous SW cats have low-grade white spotting, which is less than 50% of the cat's body, and homozygous SS cats have high-grade white spotting, which is more than 50% of the cat's body. G causes white feet and is mostly found in the Birman breed. It's either codominant with or more likely recessive to W. And W, which is normal full color. Fully white cats, of course, still have all their other color genes, they're just invisible due to the epistasis. So if you want a fully white cat to produce a non-white kitten, you need to know what color they are underneath in order to know the kitten's color. One final note before we get to practice squares: please research and write deaf characters with respect to the deaf community. Here's a couple practice squares. This is a really easy one just to start off. Just a full color cat and a heterozygous white dominant cat. Fill it out and then tell me the percents. Nice! A 50% chance for a heterozygous white dominant kitten, and a 50% chance with no white at all. But I did something fun here. The heterozygote in this scenario is Duchess from Aristocrats. She's a fully white cat with 2 non-white kittens and 1 white kitten, so she's definitely WDW. The father could have had white spotting, but I went with WW Occam's razor style since none of her kittens have white spotting. Here's another one. This time the pairing is Duchess with Thomas O'Malley, who has low-grade white spotting. This one's more difficult, so good luck. Here, we have a 25% chance of low-grade white spotting, a 25% chance of full color with no white spotting, and the last one is tricky. Their genotypes are different. One option has the kitten carrying white spotting and the other one doesn't, but the phenotypes are the same. That's a 50% chance of heterozygous white dominant. That's the last color video currently planned for the series. There's still a lot of weird, rare, or breed-specific color mutations I haven't talked about. Maybe one day I'll make a video on a few of the more popular ones, like the Finnish mutation, but there's so many, and we're always finding new ones, and we don't understand most of them. You're better off using your newfound knowledge of genetic concepts and jargon to do your own research if you want info on a highly specific, unusual mutation. Instead, the next video is going to cover fur lengths and textures. I'll see you there.